It all gets, so different, horses for courses, as it were. The application with mountain bikes, as I say, you use very little of it. You use it in very thin walls because it's so strong, and also means because of buckling issues, buckling laws, you also have to use it in relatively small tube diameters. Now this gives this kind of general sort of accepted wisdom in cycling, where steel frames are a little bit more flexible, have a little bit more nice ride feel, and they definitely do. They are more flexible than an aluminium frame. Whereas in heavy engineering, the opposite is true, because aluminium is actually a third less stiff as a material. If you had two exact blocks of steel and aluminium, that's 3 times easier to squash effectively than steel. So when you're using steel in bikes, because it's so high strength, you're using very little of it, it's actually quite flexible, which is what gives you the nice ride feel that I enjoy about steel in bike frames. Whereas with aluminium, it's not very strong, it's actually not very stiff as a material, but because it's so light, you can use loads of it. So you use it in these massive sections, and it's actually the sectional properties that give aluminium this stiffness, this idea in bikes that aluminium is stiff, steel is flexible. Whereas in heavy engineering, where you're space limited, you can't use as much as you might like. Aluminium is actually a bit of a pain to use in quite a lot of cases because it's very flexible. So just a sort of interesting aside in terms of where bikes differ from perhaps certain other disciplines. The top end steels, like the Reynolds 853, there's some other companies that make it. True Temper make an OX Platinum, Columbus make a steel called Spirit. They're all very, very high strength like this, and they do this air hardening thing. Further down the range, you've got regular chrome moly steels, strengths around 700–800 megapascals, and that's what you'll find, your sort of commoner garden frames are made out of. And again, a little bit heavier because the frames aren't quite as strong, but still more expensive than aluminium these days. It's sort of over the 90s, and aluminium kind of overtook steel as the material of choice in the bike industry, because mainly for economic reasons. Looking ahead, there are some new steels coming around, and there's some really crazy stainless miraging steels coming out. Reynolds 953, Columbus XCR, a couple of steels like this. They're drawing these things, they've got a strength of something like 2,000 megapascals, and they're drawing them down to like 0.3 mil tubes in the middle. They're incredibly thin. The difficulty is that, as I mentioned earlier, this inherent flexibility you get from having to use very thin walls and very small tubes begins to become a limitation with mountain bikes, because with a mountain bike, obviously it's a very dynamic environment. You've got a lot of rocks, you're running over stone, you've got very stiff forks, you've got sticky tyres, you've got 700mm wide bars if you're riding trail bikes and things, and there's a lot of big inputs going into this. And if the frame's actually too flexible, the rider loses confidence, they don't feel that the bike's going exactly where they want it to. And we did actually do a sole prototype in 953. It was giggly light. It was like 3.7 pounds for the frame. It was really light, and it was so pretty. It really was, in this brushed stainless steel. But it was really quite scary to ride. When you really started pushing on, you could almost feel like the two wheels like not moving in line with each other. And I broke it after 6 weeks, because the other thing about these steels is that they're very hard to pull, because they're very hard to draw. You can only get them in these extremely thin walls, and I broke it at the seat tube, top tube weld, because obviously mountain bike frames are quite compact. You have a very long seat post, so the frame's kind of out of your way. And even though I knew it was going to be a bit marginal, it was a prototype, I thought I'd give it a go, because they couldn't make me anything bigger. They couldn't make anything thicker, and lo and behold, I was proved right, and it went bang. So now I have a very pretty wall ornament. But it's not sort of, so for mountain bike applications it's not ideal, but it is beginning to gain a little bit of a foothold in road bikes, because although it's very strong and it's very expensive as well. I mean, the frame that I had made was nearly as expensive as a titanium frame, but was still £0.5 pound heavier, so it kind of had a bit of a what's the point about it. For road bikes, the thing that the Moraging steels have is that the custom builders, the traditional custom builders, can use it, because even though it is tricky to work with, it's not as capricious as titanium in terms of needing full argon evacuation to stop the brittleness and all these kind of things that I'll come to in a minute. So what these guys are finding is that the custom builders are having a bit of a resurgence on the roadside, because they can actually build something of getting on for titanium kind of performance using their traditional skills. So whilst it's not necessarily great for mountain bikes, it is finding its place. Some more pretty pictures of my bikes. Moving on. Carbon fibre. Carbon fibre is a bit of the darling of the industry at the moment, and it's a very cool material to work with when you begin to understand it, but it's also quite a scary material to work with as well, because the thing with carbon fibre is that you can use it so specifically. It's its strength and its weakness almost, because you lay up layers of carbon fibre and you can put the fibres in the directions in which the load is applied. You can use different stiffness fibres. It's very different to steels in the fact that you can actually buy fibres with a different intrinsic stiffness, whereas with steel, steel doesn't matter how you alloy it, it's pretty much 200 gigapascals Young's modulus, it just is. Whereas you can buy, different carbon fibres with different levels of stiffness. So it's an incredibly flexible material in terms of approach rather than actual flexibility. But the corollary of that is you've got to understand the physics of a bike frame extremely well to build so light with it. You've got to know that the loads in that part of the frame are definitely in that direction and not in any other directions if you're going to put just those carbon fibres there. So it allows these crazy light structures to be built. Like the new Cervelo R5 on the roadside is 570 grams for a 54 centimetre frame. On the mountain bike side, this new Scott scale has just come out. It's 899 grams for a hardtail mountain bike frame. I mean, it's immensely light structures. So if you do understand what you're doing with the physics of the frame, and you want to commit to that, then it is possible to do some pretty amazing things with it. The downsides are obviously expense. It's expensive material. It's very labour intensive to make. You're literally, taking little bits of carbon fibre and laying them up in certain ways. So it's very labour intensive, and it has to be made in a mould, which you've got to tool up for every single size and shape of frame that you make. So the capital costs involved in terms of the research and development and tooling are very, very high. But what you can get is very, very high performance parts. Interestingly, it's actually not being used as efficiently as it perhaps could be. The thing about carbon fibre is that it actually lends itself to really big monocoque structures, not really fiddly little joints. Think Lotus bike, think Chris Boardman. The interesting thing is that it was actually that bike that killed it, because on the roadside, on the track side, monocoques are so aerodynamically effective that the UCI banned them in competition about 17 years ago. So that's why road bikes still look like bikes. The manufacturers have to necessarily focus on making the bikes tubular and actually look like a regular double diamond frame, because that's the only way they can get them into competition on their Pro Tour teams. And obviously there are other issues in terms of interfaces with things like front derailleurs and seat posts, but that is getting less and less, because as many of you who are into mountain bikes will know, The word standards is a bit of a dirty word in the industry at the moment, because people seem to come up with a new standard every month and then chuck every other interface in the bin. So less of an issue as it used